Hey everyone, Steve Schmidt here again with Simple Pump Company. Today what I want to do is show you our test system. This is how we test the various cylinders that we have in the DC drives. This allows us to do a lot of real life testing on the seals, check against the pressures that we're able to do, check seal wear against certain depths. The way this is kind of structured is we have our 100 cylinder here on this system. We have our 125 cylinder on this system. This one is our suction pump, which uses the same piston and the same cylinder design as the 125. And then this is our 200, which is our largest pumping cylinder. It's a bit complex how we have this plumbed and set up, but you'll see that there are 4 little valves here. These are called pressure relief valves. And these are set to certain pressures. Now a certain pressure will allow us to simulate a certain depth. For example, the maximum depth that the 200 cylinder can pump from is 110 feet. That's equivalent to about 50 psi. So if I set this pressure relief valve at 50 psi and I start to pump, well, now what I can do is simulate that depth to look at how it wears with the seals, what it feels like on the handle. Currently we have a drive system set up on this one, the 125 and the 100, because we're doing a lot of testing on the lifetime of the motor, the lifetime of the seals, and as you can imagine, me setting this up for a couple hours to run is far easier to do than out here pulling on a handle all day. So the drive system is one that tests our own product, but it also allows us to test the lifing of those seals without having to be pumping the handle. So in today's video, what I want to do is kind of just show you each of these 4 running, and then I'll focus a bit on the 100 to give you an example of how we use the PRV, pressure relief valve, to simulate a depth and how it recycles itself and then continues to simulate that increase in pressure. So first thing I'll do is I'll come back here. And right now the 200 CA is set up to just pump into the tank without any kind of pressure. So it's really simulating very little lift, but it will give you an idea of kind of how the system works. So if we turn that on, it's a little bit noisy, but it's already started pumping water. Then if you look down below, you can see that we've got water getting pushed through the system. Now this can sit, and we run these various times throughout the day, so they're not all running at the same time. It gives the motor a chance to cool down and get a break. So that's our 200 cylinder. I've got the handle on the suction pump so that I can simulate that for you using the handle. So I'll come back here and just start pumping on it. And if you look down low, you can see that we've got water flowing through it because the water is getting pulled up through the suction pump and pushed through that plumbing and out the bottom. Okay, so this is our 125 cylinder. Very similar setup for this, just for the video today. It's running straight through, not through any kind of pressure relief valve. So it's really only lifting the water a foot or so, 2 feet. So just allow those seals to run and get some wear, but you can see as well, you've got your water coming out of the bottom, showing that water is moving and that pump is functioning correctly. Okay, so for the next test, what I want to show you is on the 100 cylinder. So it's the smallest pumping cylinder, but can handle the most amount of pressure or lift. Because you're moving the least amount of water with every stroke. And what we're going to show you here is you can see we've already kind of started it a little bit. You can see there's 40 psi on that gauge there. I have the pressure relief valve set to about 45. And what's going to happen is this pressure tank down here on the side, that's going to continue to fill up. And as it fills up with more volume, it increases in pressure. So the system pressure will increase as it runs. As that system pressure gets up to that 45 psi, what we're going to see is a large amount of water getting pushed out, because that's that valve opening up, and then it's relieving the pressure that's in the system. And then once that pressure is relieved, the valve will actually close, and then the pump will continue to repump up to that pressure again. This may take a short period of time. What you'll notice is that this one running seems a lot quieter than the other two, and the reason for that is that there's a load on the system. With these other two, it's not lifting very far, so it's very easy to do. So things are just kind of moving freely. When there's pressure, there's load on that arm. There's load on what we call the dog bone that is in between the arm and the piece that's running sideways. Oh, you can see now that that pressure has been relieved. So while it's going to keep running and the pressure is still fairly high, simulating a lot of lift, it'll take it a minute here. Eventually it'll wear out, it'll drain out all the water and allow it to reduce to a certain pressure, which will allow that pressure relief valve to close again. It takes a little bit of time to get all through that. And now you can see that the water stopped, that PRV is closed, and now we're going to put that load back on the system, and it's going to build itself back up, which again, this is great for lifing the seals, because those seals, as you have more pressure, they push up against the cylinder wall, which means they're going to wear faster. So it allows us to really understand the number of strokes at specific depths that these seals can handle, allowing you to understand better what you can expect from your system. What I'm going to do now is I'm going to close all of these, because I want to talk about one more thing that this allows us to test. I'm opening up all the valves. Now what you can see here is that is putting pressure on all of these pressure gauges. What I'm basically doing is I'm opening this up to the pressurized system. Now what this allows us to do, it allows me to shut the system off and let this thing sit for a couple of days, a couple of weeks. And what it's doing is it's showing that under pressure, all of our check valves are holding. Now those check valves are what holds that prime, so that when you go out and you pump and you leave for 2-3 weeks and you don't use it, that water should be just below that weep hole. Now, we can't test how all of the pipe is put together when it's assembled in your well, so we don't know if there's leakages there potentially, but what we can do is we can test to see if our check valves are holding. Okay? So that's another benefit to this system, is to be able to make sure that the check valves that we've designed and use are working correctly. Oh, you can see it came up to pressure again, and now it's relieving that, which is again allowing us to simulate that depth and really put a load on the system to make sure these systems can withstand the types of limits that we communicate to our customers. Go ahead and turn that off. So this system is relatively new for us. I'm starting to figure out, okay, how do we put together our test scenarios and our intervals? But what I plan to do is provide in the future, in some future videos, results of what the testing shows us in regards to the amount of hours that these motors can run, the amount of strokes that the seals can handle, so that again we can better understand the quality product that we're providing for you, and you can better understand what to expect and see when you use it in your own well. Appreciate your time today, and don't forget to subscribe.